So first, let us log into system. I'm giving the IP address, username and password. So once we log into system, let's click on start, click all program, then click on SAP HANA folder, then click on HANA Studio. So once we click on HANA Studio, then on Friday, we started to discuss about what is a package. Packages are used to group together a related information object for structuring purpose. So we have created one example for package. So this is HANA database. If you expand the system and then expand content, so we've created a package called ECC August 14. So let's go to the package ECC August 14. Expand the package, and then here you would see a sub package. Expand the sub package and master data expand. So this is what we have created on August 14. So later we started to discuss about what is an attribute view. So if we click on the attribute view, so we discuss attribute views are the reusable dimensions or subject areas used for business analysis. You can also use attribute views to join master data tables to each other. So based on this definition, I've taken an example. So we started to discuss about this example called customers. In the customer subject area, we have taken customer ID, name, country, name, region name. And in the material subject area, we have taken material ID, name and group and time and transaction data. So later we started to focus on how to create a customer attribute view. So in order to create a customer attribute view, then we tried to take technical details. Like for example, in here, if you take these customer attribute, so what are the columns and tables where this information is coming from? So if you go and go to paint, so the customer information is coming from, so let me basically take the columns and tables. The customer ID is from the table KNA1. The customer ID is from table KNA1 and the column inside the table is KUNNR. So KUNNR is nothing but the customer ID in the KNA1 table. So next coming to name. Name is also from KNA1 and the column inside the table is name1. And third one is country. The country as an attribute is also from KNA1, and the column inside KNA1 is land1. So land1 is the column in the table KNA1. The country name is nothing but the descriptive column. So descriptive columns are basically stored in text tables. So in SAP, the country text is stored in a table called the country text. Text of the country is stored in a table called T005T. And the column name inside the table, inside this table, the column name is landx. The country attribute is in KNA1, the country text is in T005T, and the column name is landx. Coming to the next one, regio. So regio as an attribute is available in a table KNA1, and the column inside the table is regio. The description for regio, which is name, is stored in a table called T005U, and the column inside the table is BZEI, BZEI. So basically on the top you have all the table names, and below to the table names you have the columns inside these tables. So coming back to the definition once again, attribute views are the reusable dimensions to join master data tables. So how many tables do we have to join over here? There are three tables, which is KNA1, T005T and T005U. So let us try to arrange. So let me try to arrange them. So I'll take three tables. One is the KNA1, the second one is T005T, and third one is T005U. The first one is KNA1, T005T, and the last one is T005U. So now let us take what columns do we require from the table KNA1. So we require, so please see what columns. KUNNR is one column, second name 1, third land 1, and fourth regio. So from a KNA1 table we require 4 columns, which is KUNNR, the second one is name 1, third one is land 1, and fourth one is regio. Now from the T005T table, what column do we require? We require landx, which is the descriptive column for country. And the last one is T005U. What do we require from T005U? BEZEI. BEZEI. So now we have three tables over here, and these are the columns inside these tables. So the next thing that we have to do, how do we join these three tables to create this customer dimension? To create this customer dimension, how do we join these three tables? So joining of these three tables in a place called data foundation. So we join these three tables when creating an attribute view in a place called data foundation. So first, what I will try to show you now, I will try to show you these three tables on the source system first, on the ECC. Then I'll show you these three tables on HANA. So first we'll see on the ECC side, and then we'll try to see these three tables on HANA. So first let us go back first to the ECC, which is the source system. So let us log on to ECC. So click Start, click SAP Logon. And to log on to ECC, double click on the ECC system. ECC stands for Enterprise Core Component or Central Component. So let us give the username. Username is Surya and the password is S capital URYA 1234 and click enter. Select the second option to continue and enter the transaction code SE11 and click enter. And then let us enter the first table, which is KNA1 table, which is the customer attribute table. So KNA1 is a master data table and the subtype in master data is an attribute. So let us enter this table and click display. So once you display on the KNA1 table, once you click display, what columns do we require from KNA1 table? From this table, what columns? Please see. What columns do you require here? We require KUNNR, we require name1, land1 and regio. I'm just trying to highlight these columns. KUNNR, land1, name1 and regio. So these are the four columns that we require from the KNA1 table. So let us view data for these columns. Click on contents. Click on contents and click execute. So once you click execute, so let's see sample data that is provided by SAP for educational purpose. SAP has provided all this data. So let's work on this data. So here it is showing you the descriptions. If you want to see the technical names, just click settings, click user parameters, and then select field name. Select field name and then click continue. So once you click continue, I would like to just show you the technical names. Now the technical names over here are KUNNR. The second one, if you see land1, name1 and regio. So let us take one example. The customer 02, the land is DE, his name is wet and the region is 08. So how do we know what is 08? Or for example, what is KP or what is CU or what is DE? So we require text for this. These are only the codes. This is the country code. This is the region code. But in order to get text for DE or in order to get text for 08, the texts are stored. So where are texts are stored? The text for country, the text for country is stored in Landex and the text for region is stored in BJDI. So let us also open basically these two tables, Landex which is in T005T and BJDI which is in T005U. Let me open both these tables. So we have taken one table. Let me open the other two tables. Create session. So first what I'm trying to do is I'm just trying to explain how we can correlate these three tables. So let me go to S11 again. Click enter and then provide the table name T005T and click display. So what is T005T? It holds country names. So from this table, what column do we require? We require the column Landex, which is the country name. So let me try to just make it. Let me decrease the size of the window. I'm just trying to decrease the size of the window. So in here, if you see now, so what is Landex over here? So what is the code, which is DE, right? The Landex code is DE. So here you have Landex, the country key. The country key is DE, and you would like to see what is the country name. Let's click contents. So what is land one? Land one is DE. Let me provide DE. And SPRAS. What is SPRAS? SPRAS is nothing but the language key. It is nothing but the language key. So the DE that you see over here, if I only click number of entries, so how many entries do you have? For a single DE, you have 29 entries. So why do we have 29 entries? Let us see. Click execute. Now please see, a DE is shown in Chinese, D is shown in English, D is shown in German, D is shown in Japanese. But do you want to see D in all the languages or in a specific language? Let's click back. If you want to see D in a specific language, then click input help. Click on input help and then select English. Select English, double click and click execute. Or click number of entries. So how many entries now? Previously 29, now only one entry. Because we try to restrict to English, which is shown one entry. Click close and click execute. So once you click execute, DE is nothing but Germany. So now we know DE is Germany, which is the description. In the similar fashion, let us also try to know what is 08. 08 is stored. Let me open another session, create session, SC11, enter, SC11, enter, a database table T005 view. This is the database table name. Click display. So let's come back to the diagram once. If you see the diagram from T005 view, what is the column that we require? BZDI. BZDI nothing but the name. It gives the name for regio. So let us try to understand what is 08. So let us go to T005 view. So here if you see BZDI is over here and the regio has the field name bland. Bland is same as regio. So here you see regio over here. In this table, this is bland. Both are same. So if you see regio is 08. Regio is 08. So let me click contents and enter the value in bland 08, which is regio. And SPRAS English, I would like to see 08 in English. And click number of entries. 27 entries. So you have 27 entries, but this bland, which is 08, you want to see in which country. Please see, the land one is DE. So let us also give land one as DE and click number of entries. Now it is only one. So we would like to see DE, which is Germany. In Germany, what is the region which is 08? And you want to see 08 in English. So let's click execute. So D, which is Germany, 08 is nothing but the region is Baden. So why are we restricting region to country? because now let's say Hyderabad. Hyderabad is in India. Hyderabad is in Pakistan. So what Hyderabad are we referring to? We're referring to Hyderabad which is in India or which is in Pakistan. So we're trying to restrict region to country. And you want to see the description in English. So it is shown the name of the region is Baden. So hope now we try to understand the relationship between data between these three tables. So now we have ECC. On the ECC side, we have three tables that we just saw, which is KNA1, the second one is T005T, and third one is T005U. So this is on the ECC side. So now we will try to do something called data provisioning. So on the later classes, once I complete modeling, then I will show you how to do data provisioning. So once you do data provisioning, either with SLT, SAP Landscape Transformation, or using BODS, Business Objects Data Services, SLT for real-time data transfer and BODS for batch. So we try to take the copy of these tables, both metadata, both the container as well as content, the data inside the table, which is the content, and the content which is held by a container. We try to do data provisioning and take the same tables to a different system called HANA. We'll see this exercise later once we complete data modeling. So already this is done. So the copy of tables that are existing on the ECC side, now we have in HANA. So now in HANA, where do we have these tables? We have these tables. On the other day, we try to see what is the difference between a catalog and a content. A catalog is a collection of schema. A catalog is a collection of schema. Under the schema, you have these different tables. So now these three tables called KNA1, T005T, and T005U are available under a schema called HANA user schema. So these three tables are grouped under a schema called HANA user. Now, what is the advantage of copying these tables from source and take these tables to HANA? What is the advantage? Now, on the source, these tables are residing on disk, and in HANA, they reside in memory. On source, these tables are stored in row. In HANA, these tables are stored in column. Here it does sequential processing. Here it does parallel processing. So exactly what HANA does, it does opposite in ECC. So with basically slow performance, and here it has higher performance, extremely high performance. So that is the reason we would like to copy these three tables from ECC to HANA via data provisioning, which is BODS. So now let us go to HANA. Let us go to HANA. So we see these three tables on the source system. So where are these three tables? Let us also see those. These three tables, you click systems, click status. So where are these three tables at the moment? These three tables, what is the database? Database is MS SQL. The three tables are basically residing on a database called MS SQL. Now let me show you in the HANA Studio. Let's click HANA Studio. Let's click on HANA Studio. Let's expand catalog. Expand the catalog. So where are these three tables? In a schema. What is the schema name? The name of the schema is HANA user schema. So let's expand the schema, expand the schema, expand the tables, expand the tables folder, and let's see whether we have these three tables over here. KNA1, yes we have. Double click on the table. So this is the columns inside the table. Do you have KUNNR? Yes. Land 1, name 1, regio. The tables are stored in column stores. Click on runtime information. Click on runtime information. The tables are stored in memory. So this is the total memory consumption, 4.9 MB approximately. 4972 KB. The number of entries are 7997 entries. These entries occupy this much space in memory, and these tables are column stores. So let us also check for other tables, other two tables, which is T0050 and 5U. If you want to check these tables, right click on the table. You can also filter. Instead of manually searching, you can right click on the folder and click filter, and then enter the table name T0050, click whole word and click OK. So it's going to show you only that particular table. T0050 table, we have T0050, and the last table is T005U. Let me right click filter and T005U. Enter the table name and click OK. So you see the table T005U. Double click. Yes, we have these three tables now. So finally, the requirement that is given by the business, we would like to translate into information view. In order to translate, now we know what tables, what columns inside these tables. So let us start creating an attribute view now. So let's go back to HANA Studio and start creating an attribute view. Once again, what is an attribute view? The simple definition of an attribute view, it's a reusable dimension to join master data tables to each other. So let's close catalog and let's go to content. So what is our package? ECC August 14. So if you expand the package, we see the sub package for master data. Right click on the sub package and click new and click attribute view. So click on the attribute view. So attribute views are also known as information views. You have to provide the technical name. The best practice to start an attribute view is with AT. It is not mandatory to always start with AT, but it is best practice. You can take any name to start the technical name. AT attribute view underscore customer. Let's provide the label. Label is nothing but the description. So we have given the label called customer. So how many subtypes do you have in an attribute view? There are three subtypes: standard, time, third one is derived. The default one is standard. A view type is an attribute view. What is the package that this attribute view is associated? The package is ECC August 14, under that SD, under that MD, master data. So technical name, description, what is the package, what is the view type, and what is the view subtype, which is standard. And then click finish. So once you click finish, now here you would see on the top there are various tabs: quick launch, KNA1, these three tables, and the last tab is customer. Now, in the scenario pane, so you see there is a scenario pane. In the scenario pane, you have data foundation, and the second one is semantics. Now, what is the data foundation? Once you click on the data foundation, a data foundation is a place where we create a relationship between tables. So we try to create a relationship between tables. So first, in order to create a relationship, first we need to add tables to data foundation. So what tables we require? We require these three tables, which is KN1, 5T and 5U. Let's go back and add these three tables at the data foundation. So we'll see the other two subtypes in tomorrow's session. Just today, I'm just trying to focus on the standard attribute view. And tomorrow we'll see derived as well as time. Okay, so now we're at the data foundation. Click on the plus icon, add objects. So here we are trying to find tables. Enter the table KNA1. So the table KNA1, so you see KNA1 is basically stored in multiple schemas because a lot of participants are practicing. So that is the reason KNA1 is in multiple schemas. But what is our schema? So the schema that I'm trying to use over here is the KNA1 at the HANA user schema. So let us find KNA1 from HANA user schema. So here we have KNA1 from HANA user schema. Select the table, click OK. So this is the table that we have. So in order to add table, click plus icon, or you can click on here as well. In the details pane, right click, add. Here also you can add tables. The second table is T005U from HANA user schema and click OK. So this is the second table. So either you can click on the plus icon from here, or you can right click and add table from here, or the other way is, the third way is, you can directly go to the catalog, directly navigate to the catalog, expand the catalog. You can go to the schema, HANA user, and you can right click on the table, just try to filter T005T, click OK. Just select the table and drag and drop to the data foundation. So either you can click on the plus icon, either right click new, add, right click and add, or you can just drag and drop from the schema to the details pane. So now, based on the requirement at the data foundation, I've taken these three tables. So when creating an attribute view, what is the first step? Step number one is to add tables to the data foundation. So that is the step number one. Now step number two. So what is step number two? Step number two is to define a relation between these three tables. So let's try to identify what is the relation between these three tables. So can I join land1 of KNA1 to land1 of T005T? And land1 of KNA1 to land1 of T005U. So basically what is the requirement? If land1, so what is the land1 D? If D is equal to D, then get So what do we need to get? Landex. What is Landex? Germany. So when I click select, you see there is a orange color highlighting over here. It means the column got selected to the output. So when I click on that, it got selected to the output. So based on the business requirement, what columns do we require for the output? Customer ID, customer name, country, country name, region, and region name. So these are the following columns are required from the output. So if I go back to the remote desktop, so here I selected Landex, which is the country name. What is the country ID? Country ID is land 1. Customer, KUNNR. Name of the customer, name 1. Region of the customer, regio. Where is this regio text stored? The region texts are stored in BZDI. Also let us click BZDI. So how many columns do we have over here? Please see the first one, which is KUNNR. Let's get to the top. In order to get to the top, you just need to click on the arrow icon, move up. Customer ID. The second one is name 1, customer name. Third one is land 1, country ID, country name, region ID, and region name. So this is known as minimal projection. What is a minimal projection? Minimal projection means selecting the required columns to the output. You see there are a lot of columns in these 3 tables, but we only select the required columns based on the business requirement. That is nothing but the minimal projection, required columns for the output. So step number 1, add tables. Step number 2, define relationship between tables. And select the required columns for the output. So in here if you see, I join land 1 with land 1 and land 1 of KNA1 to land 1 of T005T. But what is the type of join? When you select the join, you see for this join, you see the properties. If you see the join type, there are several join types over here. Referential join, inner join, left outer, right outer, text join. We need to select the join type text join. Now why only text join? The reason being, blindly we have to remember whenever you try to join an attribute table with the text table, you're trying to get land 1 description from Landex. Whenever you join an attribute table with the text table, the join type would be a text join. Now what is a text join? A text join is nothing but it is basically an inner join. Now what is an inner join? Inner join is nothing but getting common values from both these 2 tables. So when you join a land 1 of KNA1 to land 1 of T005T, you basically only get the common values. So if you have DE in land 1, DE from T005T, and get the description. But again, the description here should be shown in only a specific language. So what is the language column? The language column I would like to take in as SPRAS. So let me repeat the steps again. First step is to add tables. Second step, define relationship between tables. Third step, define the join type. So how do we know what is the join type that we have to give? Whenever you join an attribute table with a text table, the join type would be a text join. Now what is a text join? A text join is nothing but inner join. What is an inner join? Common values between land 1 of KNA1 to land 1 of T005T, D and DE, it gets the common value and gets the description. Now, how does it get description? It gets the description based on the column type, which is pras. Now, pras is nothing but the language column. So when we logged in into system, when we log into HANA, right click on the system, click properties. So what language did we log in when we log into HANA? Let's see. Click additional properties. So what is the language that we are using over here? Local A. The local A here we are using English. So when the local A is in English, the descriptions for Landex based on the user session. User has entered English. Spras, which is language key, will be English. So then it will show dynamically. This will be done by the system. If the user is logged in English, and the Spras will be English, and the Landex language will be shown in English. So this all internally system will process to show the description for Landex in English. So in the similar fashion, let us join KNA1 with T005U. So we have joined land1 with land1 and also join regio with bland. So what is regio over here? So let me just bring this table to bottom. Just select and get to the bottom and this one to the top. So the regio is nothing but bland. I try to join with bland and land1 to land1. So again, whenever you join an attribute table with the text table, the join type would be text join. The language column. So whenever you take a text join, the language column should be spras. So when one join is text join, the other one also will be the text join. So first step, add tables. Second step, define a relationship between tables. Step number 3, whenever you join an attribute table with the text table, the join type is the text join. Why only text join? Because it should give descriptions. When you would like to see descriptions from the text column, from the text table, we need to take it as a text join. Text joins are inner joins. They give descriptions based on user session. If user session in English, the description will be shown in English. And then field selection for output. So based on the user requirement, what columns do we need to take to output? KUNR land1 name1 regio, land1 description which is landex, and region description which is bjdi. So we've taken land1 twice. Let me delete this. I clicked twice. So finally, the selected columns from the data foundation is nothing but semantics. Click on semantics. So once we click on semantics, the output of the data foundation, is available in semantics. So this is the output that user will be able to see data for these business entities. We need to have at least one key attribute. The key attribute here is KUNNR. Make it as a key attribute because this is the key of the table. So in the customer attribute view, obviously customer ID will be the key attribute, which is the key of the table. And then next we have to do something called label mapping or descriptive mapping. You need to map. So who is 001 customer? What is his name? Raju or Wet. So we need to map customer ID with name 1, land 1. which is country ID with Landex, which is the description, and region ID with BZDI, which is the description for region. So here you see there are descriptions, and here you see keys. So why do we have to do descriptive mapping or label mapping? The importance of this is, now let's say user is trying to drag and drop. So in the report, suppose say there's a report over here. Now you have these columns like KUNNR, name 1, regio, BZDI. So if you don't do descriptive mapping, what happens is you need to drag and drop, okay, customer into the report. Okay, KUNNR is 001, but he will not be able to see who is 001. 001, let's say, is Raju. So in order to get Raju description, again he has to drag and drop name 1. So what we are trying to do is we are trying to do label mapping. We are tying up name 1 with customer in the back end. Do you see? What am I trying to do? I'm trying to tie up name 1 with customer. So when you tie up, what is going to happen over here is when you tie up, when you drag and drop KUNNR into the report, immediately you will see 001, his name is Raju. So that he doesn't have to drag and drop the columns twice. So that's why we're tying up name 1 with KUNNR in the backend. So in the same way, region with BZDI. So if region is 08, if the ID is 08, the description is Baden. That's what technically this is known as descriptive mapping or label mapping. So let us hide these columns because we already tied up. We're just hiding these columns. And then check for errors. Click check, save and validate. Click save and validate and click save and activate. Save and validate and save and activate. And let's see whether the attribute view got activated or not. Let's go to ECC August 14. Expand attribute views. So here you see the attribute view got activated. In order to see data preview, right click on the attribute view, click data preview, click data preview and click raw data. So once you click raw data, so let us try to filter one record. So because here it is showing you all the records, let me try to add filter. So once we created this, let us do a sample unit test. I'm trying to do a sample unit test. Click add filter, KUNNR. Click on show list of values. So let me select, simply see on the ECC side, if I go to KNA1 table, I'll do a test on 002 record. Let me do a sample unit test to check whatever we have done is correct or not. Let's go back to HANA Studio again to verify data. Let me give 002, select 002, get to selected values and click OK. So once you click OK, now after combining these three tables, now do we see 002, the customer is wet, DE is from Germany, and 08 is from Baden. 08 is nothing but Baden. So you see key, text, key and text. Now because if you double click on the attribute view, we try to join these three tables, and then it becomes a dimension or the customer subject area. So let me repeat the steps again what we have done. First, what is an attribute view? It's a reusable dimension to join master data tables to each other. So based on the requirement, I've taken three tables: KNU1, T005T, and T005U. So how do we got these tables into HANA? We have done data provisioning either with SLT or BODS, and these tables are available in catalog under schema HANA user. And to add tables to the data foundation, the first step is to add tables. Click on the plus icon to add table, or you can right click on the free space add, or you can drag and drop from the catalog into the data foundation. So once you drag and drop these tables into the data foundation, the next step is to define a relationship between tables. To define relationship between tables, join land1 of KNA1 to land1 of T005T to get the description landx. Now what is the join type? Is the text join. Text joins are inner joins. They basically show description based on descriptions based on user session. If the user is logged in English, now please see, if the user is logged in English, the descriptions are shown in English. Please see, Germany and Baden are shown in English. Now let's say I change the description. I right click on the system, I click properties, I click on additional properties, I change the local A to Chinese. Let me change the description to Chinese. Click apply and click OK. Let us go to the package. Let's go to the package again, ECC AUG 14. Expand the package, expand the sub package, and right click on the attribute view. Again, let us data preview. Now let us see this time the descriptions are stored in what language, are shown in what language. Now please see it is shown in Chinese. Let me add filter to customer. Click add filter, click KUNNR, click show list of values and select the value 002, selected value, and click OK. Now please see the descriptions are shown in Chinese. Now that is the importance of text join. The importance of text join is based on the user session, it will show the descriptions. So that's why the join that we have taken is a text join, and the language column is pras. So once we have added tables, define relationship between tables, and then the third step is field selection for output. Based on the business requirement, you can select the fields by just clicking. They become orange color and they will be available at the right hand side at the output. And finally, all the output is available at Semantics. Semantics is nothing but field selection for output. It is field selection for output. You need to have at least one key attribute, and then we have done key and text, which is descriptive mapping or label mapping. Validate, save and activate. The attribute view is created. Once the attribute view is created, in order to do a sample unit test, you can go back to source and check 002 is DE, DE means Germany, and 08 is Baden, that you are trying to get from these different text tables. DE is Germany and 08 is Baden. So in today's session, I've just shown you how to create an attribute view of type standard. In tomorrow's session, we will see the other two subtypes, which is time, and the second one is derived. If you have any questions until now, please ask me. I'll just read out your questions and answer your questions. So here, there are a few questions over here. Let me try to read them. So the first question is, why the naming convention of table names and column names are so irrelevant? What does it really mean, like KNA1, KUNNR, etc.? Okay, so in order to answer this question, basically, if you see, the SAP software was developed almost 30 years back. So during that time, most of the business that SAP has is from Germany. And especially if you see Germans, they basically developed the software in Germany because they would have more comfort level at their regional area. And then SAP software become so popular, then even outside the Germany, a lot of US customers started implementing SAP. But initially, when software was developed, they developed using Germany. So basically, KNU1 is nothing but, in German it is customer master. KUNNR is nothing but customer ID. So basically, all the table names or column names that you see is in German language. The second question: a table can be copied multiple times in multiple schemas. Yes, a table can be copied multiple times in different schemas. At any point of time, one table can be present in only one schema, but it can be copied to multiple times in multiple schemas. Can you elaborate a subtype AT? AT is nothing but it's a naming convention, like AT, attribute view, AN, analytic view, CV, calculation view. So basically, how do we know what is a key attribute in an attribute view? So simple. I mean, basically, see, for example, if the subject area is customer, then the customer ID will be the key, nothing but KUNNR. If the subject area is material, then material ID will be the key attribute. It's nothing but which gives unique values. We basically take the primary key and join with foreign key with the fact tables that is in the analytic view. So the next question, if you're trying to store so many tables in HANA, in RAM, doesn't this affect the speed of processing? The HANA main capabilities that you see is column store. It stores data in memory. And third one is parallel processing. So even though you have large quantities of data which is stored in memory, CPU can basically break larger programs into smaller subsets, and each subset of the program is individually processed and finally assembles the result and give back the result to the end user. So HANA basically does parallel processing rather than doing sequential processing. So in that way, it manages effectively. Next question, why do we need to link tables? So we link tables to create a relationship and get meaningful information. Unless and until we link these tables, we would not be able to see the descriptions for region, the descriptions for country. So we are creating a subject area. So after defining relationship between tables, we are creating a subject area, and that subject area is known as a dimension. A dimension is nothing but the perspective at which you would like to analyze data. But if you want to see more about this, we need to wait until the analytic view is created. So once we create an analytic view, then we would be able to see data in different perspectives like customer, material, time, company code. So if you want to change from one subtype to another subtype, so basically a subtype is decided when we create. So each subtype is different in nature. So we take for a specific requirement, we take a subtype and then we create. So in SAP, generally we create X and Z. Is there any restrictions in HANA? There are no restrictions as such. In SAP, we have Z and Y in ABAP application layer. In HANA, we do not have any restrictions. You can use any naming convention based on the company naming convention document. So we have next question. We have hidden name one and other two columns, but in the output it is showing all the 6 columns are displayed. Yeah, because this is a developer perspective. So when we basically see the output, we are only seeing the developer perspective. But when a user see, so user basically sees all these outputs in reporting tools like Business Objects BI, Tableau, TIBCO Spotfire, IBM Cognos. So basically there are different front-end tools where user will try to visualize data. So when we see it there, you see only one column, KUNNR. Then they have an option to select key and text, text and key. So if we select key and text, both name as well as description will be shown. That is on the user perspective. Thank you everyone to attend today's session. Please do attend tomorrow's session. So in tomorrow's session, we'll see the two different subtypes, which is time and derived. And later, the coming, so after we complete this, then we see how to create an analytic view and subsequently a calculation view. Also do read the material HA100, which is Introduction to HANA, and do practice exercises. If you have any questions, please email me. Good morning and good evening to everyone. Have a nice day. Thank you. I think we have one last question over here. Let me see, one last question is coming in. While checking the table memory, I saw the disk. So does HANA also use disk space? Yes, HANA also uses disk space. So that is the secondary way to store data. So the primary way HANA stores data is on memory and the secondary is on disk. Okay, thank you. See you tomorrow.